In this module, we will study about isomers and isomerism. Jasmine attended a summer camp during her vacations to explore her creativity. In the summer camp, she learned to make beaded necklaces. Now, Jasmine has some beads and threads, and she is trying to make some necklaces. Some designs created by Jasmine are as follows. Look at these designs carefully. Jasmine arranged beads in various ways to create different designs. Similarly, in organic compounds, various arrangements of carbon atoms are possible, leading to different structures. Let us consider an organic compound butane having molecular formula C4H10. If the fourth carbon atom of this straight chain is joined in the side chain, it gives another structure having the same molecular formula C4H10. These compounds contain equal number of carbon and hydrogen atoms, but the arrangement of the carbon atoms in them is different. Organic compounds having the same molecular formula but different structures are known as isomers. The phenomenon of the existence of two or more compounds having the same molecular formula but different structures is known as isomerism. Isomerism can be broadly classified into structural and stereoisomerism. Let us start with the structural isomerism. The phenomenon in which two or more compounds with same molecular formula differ from one another in their chemical structures due to the different arrangement of atoms or group of atoms in their molecules is known as structural isomerism. Structural isomerism can be further subdivided into the following categories: chain isomerism, position isomerism, functional group isomerism, metamerism. In this module, we will study only about chain and position isomerism. Let us begin with chain isomerism. Two or more compounds that have the same molecular formula but differ in the arrangement of carbon atoms in straight or branch chain are called chain isomers. This phenomenon is termed as chain isomerism. For example, the molecular formula C5H12 represents three chain isomers having different structures. Pentane. Now it's your turn. The organic compounds having the same molecular formula but different structures are known as, and your options are option A, isobars, option B, isomers, option C, allotropes, and option D, isotopes. Here is the explanation. The carbon atoms can be arranged in several ways to give different structures. A different structure gives different compound with new or different properties. Let us learn about the position isomerism. Two or more compounds that have the same molecular formula but differ in the position of the substituent atom or functional group on the carbon atom are called position isomers. This phenomenon is termed as position isomerism. The molecular formula C4H8 represents the following two position isomers, but-1-ene and but-2-ene. One more isomer of butene is possible, that is 2-methyl-prop-1-ene. In 2-methyl-prop-1-ene, the same number of carbon atoms are arranged in a branch. Therefore, this is called chain isomer of 1 and 2. Now it's your turn. From the listed options, which one is the chain isomer of 2,2-dimethylbutane? The correct answer is option A, hexane. Here is the explanation. The molecular formula of both hexane and 2,2-dimethylbutane is C6H12. Let us have a quick recap. Organic compounds having the same molecular formula but different structures are known as isomers. The phenomenon of the existence of two or more compounds having the same molecular formula but different structures is known as isomerism. Isomerism can be broadly classified into structural and stereoisomerism. In this module, we will first study about some general rules used for the nomenclature of organic compounds. Then, we will learn how to write the IUPAC names of alkanes, alkenes, and alkynes. We will also learn how to write the structural formula of an organic compound from its IUPAC name. There are about 7 billion people on Earth. What is their primary identity? In most of the cases, it is their name. What will happen if you do not have a specific name? There will be chaos all around. So name is essential for us. As the number of carbon compounds is in millions, their primary identity is also their name. So, there is a specific system for the nomenclature of organic compounds. Nomenclature implies assigning proper name to a particular compound on the basis of certain standard rules to make their study systematic. There are two systems employed for naming of organic compounds. These are trivial system and IUPAC system. Now, we will learn about them in detail. Let us begin with trivial system. In the early stage of the development of the organic chemistry, there was no systematic system for assigning names to the organic compounds. In the beginning, the organic compounds were named after the source from which they were extracted or obtained. These names were called the trivial names or common names. For example, formic acid derived its name from the Latin word formicus, which means red ants, because the compound was first obtained from the red ants. Let us discuss some drawbacks of the trivial system. Trivial names were individualistic and unsystematic. The same compound was given different names by different persons, which gave rise to confusion. It was not a systematic system to give names to millions of organic compounds. The drawbacks of the trivial system have been overcome by a systematic nomenclature system given by IUPAC. IUPAC refers to the International Union of Pure and Applied Chemistry. This system adopts certain uniform rules to write the names of the organic compounds in a systematic manner. The names which are assigned on the basis of these rules are called the IUPAC names. As per the IUPAC conventions, the IUPAC name of an organic compound consists of three parts. These parts are root word, prefix, and suffix. Here, root word represents the number of carbon atoms present in the chain. Prefix is. The following table shows the root words for the chain of varying lengths. The following illustration shows the root words for the chains from 1 to 6 carbon atoms, meth for 1 carbon atom, eth for 2 carbon atoms, prop for 3 carbon atoms, bute for 4 carbon atoms, pent for 5 carbon atoms, and hex for 6 carbon atoms. There are two types of suffixes, primary suffix and secondary suffix. Primary suffix is always added to the root word to indicate whether the carbon chain is saturated or unsaturated. For example, suffix "ane" is used for hydrocarbons containing only carbon-carbon single bonds. Suffix "ene" is used for hydrocarbons containing a carbon-carbon double bond. Suffix "ine" is used for hydrocarbons containing a carbon-carbon triple bond. Secondary suffix indicates the presence of functional group in the organic compound. If a compound contains more than one functional group, then one of the functional group is treated as principal functional group and is regarded as secondary suffix. The other functional groups are regarded as substituents and are denoted by prefixes. The following table shows the prefixes of some common functional groups. Some common secondary suffixes that are used to represent functional groups are shown here. If the parent chain contains 2, 3, or more double or triple bonds, then the numerical prefixes such as di, tri, tetra, etc. are added to the suffix. Remember that extra a is added to the root word if the suffix to be added begins with a consonant. For example, butadiene. Remember, while adding the suffix of a functional group to the prefix, the terminal e of the root word is dropped if the suffix begins with a vowel. Here is an example for better understanding. The terminal e is retained if the name of suffix begins with a consonant. For example, the name of this compound is butane 1,2-diol. Now let us study about prefix. The presence of the substituent or side chains are represented as prefixes and are placed before the root word. These may be alkyl groups. Names of alkyl groups are derived by replacing the terminal ane of the corresponding alkane by the suffix -ile. These groups contain one hydrogen atom less than the alkane. For example, the removal of one hydrogen atom from the molecule of methane forms methyl group. Similarly, the removal of one hydrogen atom from the molecule of ethane forms ethyl group. Functional groups which are not regarded as principal functional groups are also represented by their respective prefixes. Let us consider the following compound. Can you write the IUPAC name of this compound? The compound has a chain of 5 carbon atoms. It contains 2 functional groups. It also contains a double bond. Thus, a complete IUPAC name of an organic compound may be represented as. So, the IUPAC name of this compound is 4-chloropent-2-ane-1-oic acid. Hydrocarbons are the organic compounds which contain carbon and hydrogen atoms only. They may further be classified into 2 classes: saturated and unsaturated hydrocarbons. Alkanes are following are the structures of alkane. Hydrocarbons are the organic compounds which contain carbon and hydrogen atoms only. They may further be classified into 2 classes: saturated and unsaturated hydrocarbons. Alkanes are saturated hydrocarbons. Alkenes and alkynes are the unsaturated hydrocarbons. Following are the structures of alkane, alkene, and alkyne. Now we will learn about the IUPAC nomenclature of alkanes. In case of straight chain alkanes, the suffix -ane is added to the root word. Following illustration shows the IUPAC names of some of the alkanes. Let us write the IUPAC name of the following hydrocarbon. First, count the number of carbon atoms in the chain. Since there are 6 carbon atoms present in the chain, the root word is hex. Only single bonds are present between the carbon atoms, hence the suffix is -ane. Finally, the IUPAC name of the given hydrocarbon is hexane. The alkanes having no branching are termed as normal alkanes or N-alkanes. For example, N-pentane. Let us discuss the rules for naming branched chain hydrocarbons. First of all, select the longest continuous chain of the carbon atoms present in the molecule. Let us consider the following alkane molecule. 2 possible selections for the parent chain for this molecule are as follows. Can you predict which selection of parent chain is correct? In first case, the parent chain contains 9 carbon atoms, whereas in the second case, parent chain contains 8 carbon atoms. Thus, the first selection is the correct one. If the 2 continuous chains of the equal length are possible, then select the one with the maximum number of substituents. Look at the example for more clarity. Let us discuss the rules which are used to decide the position of the substituent on the parent chain. Numbering of the carbon atoms in the parent chain is done from the end, which gives a lower number to the carbon atoms having the substituents. For example, if CH2CH3 is a substituent, then the correct numbering of the carbon chain is as given by B. The numbering of the carbon chain as given in A is wrong because it gives a higher number to the carbon atom carrying the substituent. According to the rule, the IUPAC name of this compound is 3-ethyl-octane. Another rule used for numbering the carbon chains is the lowest locant rule. When two or more substituents are present, then the end of the parent chain that gives the lowest set of the locants is preferred for numbering. For the given compound, there are two possible sets of locants, 2, 4, 6 and 3, 5, 7. The correct set of locants is 2, 4, 6, while the incorrect set of locants is 3, 5, 7. If the same substituent occurs more than once, then the prefixes di for 2, tri for 3, tetra for 4, etc. are attached to the names of the substituents. Can you write the name of this compound? The name of this compound is 2,4,6-trimethyl-octane. The positions of the substituents are indicated separately, and the numerals representing their positions are separated by commas. If the two substituents are found in equivalent positions, that means at the same position from the opposite ends, then the lower number is given to the one coming first in the alphabetical order. Can you write the name of this compound? The correct name of this compound is 3-ethyl-5-methylheptane. Let us discuss the nomenclature of alkenes. In case of straight-chain alkenes, the suffix -ene is added to the root word. Following illustration shows the IUPAC names of some of the alkenes. Let us find the IUPAC name. First, count the number of carbon atoms in the chain. Since there are 5 carbon atoms present in the chain, the root word is pent. Since in this chain, double bond is present between the first 2 carbon atoms, the suffix is -ene. Finally, the IUPAC name of the given hydrocarbon is pentene. In case of straight-chain alkynes, the suffix -ine is added to the root word. Following illustration shows the IUPAC names of some of the alkynes. Let us find the IUPAC. First, since there are 5 carbon atoms present in the chain, the root word is pent. Since in this chain, triple bond is present between the first 2 carbon atoms, the suffix is -ine. Finally, the IUPAC name of the given hydrocarbon is pentyne. Can you write the IUPAC? The name of this compound is butane-1-ol. Let us study about the nomenclature of compounds containing functional groups. Select the longest possible chain of carbon atoms containing the functional group, whether it be the longest possible chain or not. Here is an example for better understanding. The parent chain contains 5 carbon atoms rather than 6 carbon atoms. Numbering of the parent chain is done in such a manner that the functional group gets the lowest possible number followed by the double and triple bond, even if it violates the lowest locant rule. For the following compound, 2 sets of the locant are possible. According to you, which one is correct? Numbering of the atoms in the parent chain should be done in such a way that the carbonyl carbon gets the lower number. Hence, the numbering of the first compound is correct, and the IUPAC name of this compound is 6-ethyl-heptane-3-one. When a chain contains a functional group in which carbon atom is present, such as CHO, COOH, COOR, CONH2, COCl, CN, etc., they are always given the number 1. However, the number 1 is usually omitted from the final name of the compound. The IUPAC names of these compounds are 2-ethylhexanoic acid and 2-ethyl-2-methylhexanal respectively. Let us try to write it is 2-methylpropane-1-ul. Now, we will learn about the writing of structural formula from IUPAC name. Write the number of carbon atoms according to parent chain. Now, number the carbon atoms from any end. In the parent chain, the position of the bond is located according to the suffix -ane, -ene, or -ine. Then, attach the substituent or functional group at the mentioned carbon atom. Now, satisfy the valencies of carbon atom by attaching required number of hydrogen atoms. For example, write structural formula of 2-chloro-4-methylpent-2-ene. Step 1. Write the carbon atoms of the parent chain. Step 2. Number the parent chain. Step 3. Locate the position of bond. Step 4. Attach substituents. Step 5. Now, satisfy valencies of carbon atoms by adding hydrogen atoms. On combining all these steps, we can name this compound as 2-chloro-4-methylpent-2-ene. Let us have a quick recap. Two nomenclature systems are used for the naming of the organic compounds, which are Trivial Nomenclature System and IUPAC Nomenclature System. The IUPAC system adopts certain uniform rules to write the names of the organic compounds in a systematic manner. The names based upon these rules are called the IUPAC names. As per the IUPAC conventions, the IUPAC name of an organic compound consists of three parts. These parts are root word, prefix, and suffix.